At this point, you know what has happened. A tyrant has invaded a peaceful, democratic nation against all logic and morality. An invasion of a sovereign European nation of this magnitude has not been seen since 1939. The invasion of Poland and World War II at large was dominated by the tank, a technology that shaped the battlefield of World War II, a technology born out of the trenches of World War I, a war defined by artillery and machine guns. The tank served as a weaponized shell to burst through defensive positions. Poland's resistance to this new battlefield-defining weapon relied on light infantry-carried anti-tank rifles, towed anti-tank guns, and mechanized anti-tank vehicles. Those anti-tank rifles were attempting to solve one crucial problem: a weapon that could be mass-manufactured and put into the hands of individual soldiers. A lightweight piece of equipment that could be quickly moved around the battlefield. The tanks the Polish most commonly faced were the German Panzer I and II and the Soviet T-26, both of which had maximum armor thicknesses between 13 and 20 millimeters. The Polish, in anticipation of this new threat, had developed the Model 35 anti-tank rifle, a lightweight, high-powered rifle capable of penetrating 20 millimeters of armor from 300 meters away. However, a projectile that exhausted its kinetic energy in penetrating the armor, with little left over on the other side, was of little use. Lucky shots to critical engine components located on the rear of the tank may cripple it, but if the Germans or Soviets discovered this rifle had been manufactured in such large numbers, countering it was as simple as adding slightly more armor to critical areas. Poland fell in a single month. Today, we are 2 months into Russia's invasion of Ukraine, and despite being equipped with modern tanks with modern reactive armor, they have made little progress. The nature of war has changed radically since the days of the Blitzkrieg across Europe, where once tanks rampaged unimpeded through forest, field and town. In the modern battlefield, against a well-equipped enemy, lone tanks have become large, high-priority targets for advanced infantry-carried missile systems, capable of taking out even the most advanced armor from miles away. While Russia's military incompetence cannot be ignored, the importance of these lightweight anti-tank devices cannot be understated. Countries around the world have developed their own variants of these weapons, all highly capable anti-tank devices, and many are in the hands of Ukrainian soldiers defending their country against a tyrant. But one has become a symbol of this war. Like the Spitfire of the Battle of Britain, it may not be the most numerous, but it has become an icon of a country under siege. St. Javelin of Ukraine, a weapon purpose-built for a Cold War scenario, designed to be put into the hands of individual soldiers, purpose-built to take out wave after wave of Russian tanks. This is the insane engineering of the FGM-148 Javelin. The Javelin began its development in the latter years of the Cold War, designed to fulfill exactly the role the Polish anti-tank rifle sought to fill, a lightweight and mobile anti-tank weapon that would allow individual soldiers to quickly target tanks and escape to cover before being seen. In total, the Javelin system weighs just 22 kilograms, light enough for a single soldier to move around the battlefield, enabling guerrilla warfare tactics to be used against an invading army. The Javelin is so much more than a simple rocket-propelled explosive, like the RPG. The Javelin is a fire-and-forget weapon, capable of guiding itself to the most vulnerable region of a tank from miles away, and bypassing even the most advanced reactive armor, allowing soldiers to target, fire, and escape to safety. In order to do this, the Javelin employs ingenious bits of technology. To begin, the soldiers need a method of spotting and locking onto a target. This starts with the night vision sight lens, located here. Despite being called the night vision lens, this device provides soldiers with a 4 times and 9 times magnification infrared sight that works in both day and night, allowing soldiers to spot enemy tanks from a distance, even in low visibility situations. This lens is part of the Command Launch Unit, or CLU, which attaches to the expendable rocket tubes that contain the round. The fact the tube is detachable makes the CLU by itself an incredibly useful piece of equipment. Soldiers frequently carried these units on patrols in Afghanistan and Iraq when the threat from enemy armour was low, simply because they provided excellent infrared sighting capability. Once connected to a launch tube, the soldier can flip this switch from off to night mode, and the cooling unit of the CLU will begin to cool down the infrared detectors to their required temperature, taking 2 to 3 minutes. The day mode switch provides sighting capability but cannot activate the seeker. Once the night vision sight is adequately cooled, the soldier has full missile capability. From here, they have several selections to make using the left-hand grip. A range of sight options can be selected using the sight selection switch located here, switching between the wider 4x sight or the more narrow 9x sight, and between night and day imaging settings. There is also a filter switch which applies a filter to the night vision sight to make enemy detection of the infrared sight more difficult, while the focus setting simply adjusts the focus of the sight. Once a target has been identified, the user can flip a protective cover and press and hold the seeker trigger on the left-hand grip, which activates the seeking locking sequence. This also activates the firing trigger on the right-hand grip. Over here, the user can select a firing mode with 2 options, direct and top, which change the trajectories depending on the object being targeted or the surrounding area. The top trajectory is ideal as it targets the least protected section of a tank, but top may not always be possible. The target could be under an overpass or some other obstacle. This directional pad allows the user to adjust gates manually around the perimeter of the target's profile. This is essentially visually training the seeker on the target. Once locked, the image is saved into the seeker and the user can pull the trigger. From here, things happen extremely quickly. A launch motor fires, pushing the seeker out of the tube with just enough force to get it clear of anyone nearby, about 4.5 meters. This minimizes recoil and makes the system incredibly easy to use, even allowing it to be launched from inside buildings without fear of the backblast turning the building's interior into a pressure cooker. As the seeker leaves the tube, 2 separate spring-loaded fins deploy. The front set of 8 fins, referred to as the wings, provide lift and stabilization to the seeker, while the rear 4 are controlled by the flight computer to guide the seeker to its target. The control fins are also helped along by 4 thrust vector control vanes around the nozzle of the rocket motor, which can vector the exhaust of the rocket to provide additional control. At this point, the user's job is done. They can get back behind cover or change position, which is especially useful after giving away their position while firing. The seeker is controlling itself at this point. The image initially locked into the guidance electronics is used to guide the seeker towards its target. But the seeker also has its own infrared imaging camera mounted on its nose. The goal of the guidance computer is to keep this image in the center frame using the control fins and thrust vectoring vanes. To do this, it uses pattern recognition algorithms to keep track of the target and updates the target reference image every frame to make the job of tracking the continually changing image as easy as possible. As the seeker closes in on the target, a sequence of events occurs incredibly quickly. The seeker has a 2-stage shaped charge. Shaped charges are fascinating. They use fluid dynamics and the kinetic energy of the blast to slice through armor. Shaped charges consist of the charge itself, shaped with a hollow indentation where a metal liner is placed. When the charge is detonated, a pressure wave forms behind this metal liner, deforming and accelerating the metal into a lance-like jet of ultra-fast metallic particles that cut through armor like butter. Contrary to the shaped charge's other name, heat, which stands for high explosive anti-tank, this is a purely kinetic mechanism. The shaped charge effectively creates a hypersonic projectile at point-blank range. The metallic liners chosen need to be ductile so that they readily deform and form into a linear jet, maximizing the projectile's penetration ability. A brittle fracture of the liner would result in large chunks of particulated metal that would reduce the penetrating power of the metal. But this needs to be balanced with the velocity of the jet, which will lower with heavier elements. The Javelin itself has two stages. The first stage uses a molybdenum liner, while the main charge uses copper. This two-stage design allows the Javelin to deal with modern reactive armor more effectively. Reactive armor are those strange box-like structures you see on modern tanks, and they were created specifically to deal with shaped charges. Reactive armor works by placing an explosive charge between two metal plates. When a jet from a shaped charge strikes the upper plate, it detonates the inner explosive. You may think this could damage the tank, but the tank's lower armor is more than capable of dealing with the relatively blunt pressure formed by the reactive armor detonation. The outer plate then flies outwards to disrupt the incoming jet, while the shockwave formed by the detonation also breaks up the stream of metal approaching the tank. The first stage of the Javelin is designed to trigger these reactive armor boxes before the main charge detonates. The second charge can then cut through the inner armor unimpeded. Many modern tanks do have secondary defenses to protect against threats like this, like Russia's active protection system, Arena. This system uses radar to detect incoming threats and activates a buckshot-like munition that strikes the incoming threat. This detonates the shaped charge far enough away from the tank that the jet disperses into too large of an area to effectively pierce the armor. However, the Arena active protection system struggles to deal with top-down attacks, something the Javelin is designed to do. And we are starting to see photos of rudimentary cages placed on top of Russian tanks to defend against top-down attacks. It's important to remember that the footage we are seeing is going to be skewed in favor of Ukraine. This is an ongoing battle where morale is vital. We aren't going to see battles where anti-tank munitions failed. The age of the tank is far from over. It's still a vital tool that has advanced with new modern threats. However, one thing is for sure. Russia is losing an astronomical number of tanks. Russia's incompetence has been their own worst enemy. Fuel logistics have left tanks stranded on the roads, air cover against drones has been lacking, and all too frequently we are seeing tanks without adequate infantry and artillery support to deter and defend against these anti-tank munitions. The importance of military tactics cannot be understated. Competent leadership and logistical support makes all the difference. In our ongoing